Good afternoon, everyone, and thank you so much for joining, taking your models to the next level with Azure Machine Learning. My name is Henk Boelman, and I hope everyone can hear me all right. So let's get started. In this session, we are going to have a look about how we can do text analytics with Microsoft Cognitive Services. Going to build a model with automated machine learning, build an advanced model with Azure Machine Learning, and we are going to optimize that model later with hyperparameter tuning. All this code is available in this presentation. I will share the resources a little bit later, and this presentation is also available afterwards. So what is our story? Everything is going to be tied up with a story today. So we are going to talk about Tailwind Traders. It is a global retail company, and they want to expand into new retail markets and are evaluating the clothing space. Initially, they have no knowledge of machine learning or natural language processing. So they want to start with something simple and then build on their expertise to create more advanced models. And we will walk you along the path that Tailwind Traders likely will take when developing their text-based analytics services. So the first services we are going to look at are Microsoft Cognitive Services. So why would you want to use this? First of all, they're very easy to use. So you don't have to do the actual machine learning yourself. You just have to implement an API. They're very flexible because it is calling an endpoint. And then you can call an endpoint, an API endpoint from every language, like from Android, from Python, from C#. It doesn't really matter. And they're well tested because we also run them within our own systems, like within Azure Machine Learning, within Bing. And there's a lot of sample code. So this will get you started really quickly. So what Tailwind Traders wants to do is to find out what type of products they need to sell when they want to expand based on reviews. So what they want to know is when they ever talk about something, if something is classified as positive or negative. Like, is it people negative about pens or are people positive about pens? That is what they want to do. So there is a service, Cognitive Services, available, that is the text analytics, and that can do that for you. So if you put in a sentence, you send it to an API, it will analyze your text, and it will tell you if what type of language it is there. It will extract your key phrases like, hey, this specific sentence is about service, food, a restaurant in London. So it can extract those key phrases from you, and it can tell you the sentiment about that sentence. It can extract named entities out of it, like it sees, hey, this is about London, that is a location, and it can actually point you to a Wikipedia article where you can read more about London. So this service is fine. It can do those things for you. So I'm not going to dive in too much into cognitive services because our docs have really great examples about that. So you can go to aka.ms and find this doc, have some videos on how to do that. But I mostly want to talk how we now get from cognitive services to Azure Machine Learning. So why do we need it? We talked a lot about cognitive services in the past few minutes and how great they are, and they enable you to get started with a business scenario without needing to write. Okay, you need to write you of course need to write some code to actually use them in your solution, but you don't need to write code to actually create the services. However, we noticed that it is like always the 80-20 rule. And that means this service will work for 80% of your business needs, but for the other 20%, you need something custom, especially if your text is something like this. I love the sweater, but hated the pants. It doesn't know that loved is for the sweater and hated is related to the pants. So it will just classify this sentence as negative. And that is not what we want. We really want to get the insights out, and that the sweater is fine, that everyone loved that, but the pants were like, not that good. So that is what we want to achieve. So how do we go from there? I'm a developer myself, I've developed websites for the last 20 years, and I've always done like the traditional programming. So I would create a function, run some input to that function, and I get an answer. And with a function, I mean a lot of if then else, some mad things, so just basically a functioning code. And it gave me answers. But with machine learning, that is shifted. So instead of me programming the function, the computer let create that function by giving it a bunch of answers, run input through it, train it, and I have a function. And in other words, that function is called a model. And what is in there in that function, in that square, it is basically just a function, but it is generated by the computer. And we are going to look how we can generate that function. And for that, we're going to use Azure Machine Learning Services. So what are Azure Machine Learning Services? Azure Machine Learning Services are a set of cloud services. So it is not just a single thing. It can be controlled using the Azure CLI, Python SDK, and the web interface. And it enables us to prepare, build, train, manage, track, and deploy models. So basically, it's covering the whole machine learning lifecycle for us, from managing our data up to running this model and get feedback in production. And I said a set of Azure cloud services. So what do you get? You get, of course, an Azure Machine Learning component, but you also get a Docker repository or a Azure container instance, and you get an Azure Key Vault and a blob storage. So it are all well-known services combined. So, but before we get started with any custom machine learning project, it is always good to have a baseline. I think baselines are very important, especially for companies like Tailwind Traders, because a baseline enables them to estimate the results before they just go and grab a state-of-the-art buzzword model and put it in production. Azure Automated Machine Learning Service enables you to very quickly get started with building baseline models without even having to write a single line of AI code, and it works kind of as is. It works as follows. You provide your data, the tasks that you want to accomplish, and the constraints for your tasks. And what it will do is, it will identify patterns from you in data, and it will try to apply them to many different models. It trains these models in parallel, and then it will return the best baseline model for your task, giving the constraints. And then you can pick out that model, run it, and improve it later on. So here's a cool animation. You will see it will pick out all the different models, and then it says, hey, this model is 95% accurate on our test set, and we pick that model and continue from there. So let's have a look how that looks in Azure Machine Learning. We will dive into the interface a little bit later. So what everything is, how everything works. But now I'm just going to pick out this automated machine learning task and tell you about datasets. So when we start a new automated machine learning run, we have to just click the button, and then we have to link to a dataset. So datasets are managed here. And what you basically do is say create a new dataset from local files, in this case, or from a data store. And it will manage the dataset for you there, and it will version it there. So all your experiments can connect to the dataset and exactly use the same data in their solutions. So if you do a dataset from data store, you can, I will show you later how to make data stores. Actually, I can show you now. You can choose from these different types. So your data can come from a blob storage. So it can be like CSV files or anything you want, data lakes, SQL, Postgres, and MySQL. And from those data stores, from the data on those data stores, you can create data sets. So here we go. And I have created our clothing ML dataset. I've done that a while ago, but you see it is 1.8 megabytes, and I've created it already in February, a long time ago. You can create profiles, and here is a piece of sample code in Python how you can consume this actually. You can create a new version from it, And then our machine learning models can talk to that new version, our training algorithm. So we go to automated machine learning and we will create a new run and pick our closing data set. We can click on that and we should be able to see a small preview from it. So you see the first like 100 lines. Oh, what is in it? So here are just basic sentences like this is perfection, so pretty and flattering. And the rating is a 5, so the ratings are between 0 and 5. So let's find a negative one. Okay, there are a lot of positive ones. Here is know about that one. That's not a good one. I was really hoping to like this, but they didn't, and this is a 1. So there are a lot of samples. There's a piece of text and a rating. So this is a labeled data set that we're going to use. We click on next. We select here. We create. Let's create a new experiment. NDC Sydney. And we specify the column that we want to predict. So in this case, we want to predict the rating. And we select a compute cluster. I'll dive into a little bit later about what compute clusters actually are and how we can create them. We click on next. Is there a task I want to do? Is I want to have a classification task. I don't want to have regression and time series, but they're also here. And you can enable deep learning if you want to get some higher accuracy. Click finish. It is now starting to create a new experiment and create a new automated machine learning run. And this run will actually take, I think, 30 to around 30 minutes before it is completed. So let's go back and go to a run I've already did a few days ago. So we can click here and we can see indeed it takes like 28 minutes for it to be finished. And here it shows us the best model. But how did it get to this best model? So under models, we can see all the things it tried with the names of the different algorithms. And here we see that the algorithm, this algorithm, logistic regression, is the best. We can click a few explanation, and if this is your thing, you can just dive into all the explanations why this is actually the best model. We can pick out that model, and we can now start using this model in our solutions. So I hope this illustrated how quickly you can get started with Azure Machine Learning by just having some data and let Azure Machine Learning figure it out and create a baseline, which on later you can improve. So you can go to our docs website, and of course there are lots of more samples on how to do this. But now that we have our baseline, we have our foundation, we can pick some state-of-the-art NLP framework to improve our model and make it more accurate. And for this, we're going to use NLP Architect, aspect-based sentiment analysis. So what this framework can do, it can actually tell from the previous slide that the pants is nice and the blouse is not nice. So it can highlight and combine those things. So it's a pretty cool framework. So I highly recommend you reading about this if NLP is your thing. So, but with starting to do this as a company yourself, there are a lot of challenges to overcome because we solved lots of things with traditional programming. We have our DevOps pipelines. We know how to work together. We don't zip and deploy, hopefully, anymore. But with machine learning, that is still a thing. So we have to find something to manage our environmental dependencies. We have to find a way how we can work together as a team. We have to manage where our data is. I already gave you a small peek that we can use data sets for that. And we have to manage our compute. Not everyone in our team will need to have access to this massive CPU compute on their desk. We need to do that somewhere in the cloud centralized. And of course, our model, especially the data, it needs to be compliant. And we need to be able to explain what our model is doing and why it is doing it and how. And we need to find a way to distribute our training, because if our model becomes bigger and bigger and bigger, our small machines can do like a very small version of it, but training the big model and retraining it like every night, that needs to be done somewhere else. So, and with distributed training, there are a lot of challenges we need to manage. So of course, there are a lot of dependencies and containers. We need to be able to schedule job, distribute data. We need to be able to scale in and out our resources, because we don't want to pay for resources we don't use probably. We want to find a way to provision our clusters and virtual machines, centralize and store our results. Of course, it needs to be secure. We don't want anyone to be able to access our data, and we need to be able to act on failures. And Azure Machine Learning Service, Azure Machine Learning can help us with that whole process. So if we look at the typical end-to-end machine learning process, it all starts with managing our data and preparing our data, because our data is never clean. It is always messy. So we have to have it somewhere stored centralized and then get it ready for our machine learning model to actually be able to train on. Then everyone wants to work in their own favorite IDE. If it is Visual Code, Jupyter Notebooks, doesn't matter. It all should kind of work. Everyone should have that freedom to choose whatever they want. But then we need to train and test our model, and we want to do that in a centralized way. And we can use Azure Machine Learning clusters for that. So when the training is done and we're happy with our model, we need to register this model. And registering these models should be somewhere central and somewhere versioned. Because I told you, it is just a function we make. So someone actually needs to pick up that function and use that model in like a bigger solution, in a bigger piece of software, and need to be able to update it and need to have control about what version that model is, because it's the same thing you do with a NuGet package. You just don't right-click update NuGet packages without testing it properly. So that is the same thing, the same way with a model. You want to be able to update it and test it well before you build an image and deploy that into production. So let's see how we can get started with Azure Machine Learning. So first we need to prepare our environment. Then we need to start experimenting with our model and our data. And then later on we can deploy our model and actually run this one in production. So preparing our environment. I already gave you a peek how it looks like, but now we're going to start from scratch. So the first thing what we need is a workspace. And from now I'm going to show you Python code on how to create these things, because I think if I show you Python code, then you also maybe get a hint that we can version this code so everyone is able to read how we have created these resources. Of course, you can create these resources with an Azure CLI or an ARM template, but my preference is still to create these ones in code and commit the code. So I say here, workspace is create, and I give it a name. Give it a subscription ID, point to the resource group where I want to have it, and which location I want it. And this is already a very important choice that you need to make when deploying these workspaces. So not every location has GPU-enabled machines available, like the NC6 and the NV series. So before you create your workspace, think about what kind of compute you would need to train your machine learning workloads, and then create that workspace in the appropriate region. So when you have created your workspace, you can write out a config file. Check in that config file, there are no security details in that. And then everyone else can say, load workspace from config. They can connect to that workspace. If you're not authenticated, it will just pop up your AD, your Microsoft login, you enter your credentials, and if your credentials have access to that specific workspace, you will be granted and you can work there. And this is how it looks. It is available outside the portal and inside the portal. But the outside of the portal interface is, of course, it looks the best. And that is available on ml.azure.com. So we see a lot of menu items. We see something that we can create our models, something with a part where we can have all our assets like data, logging, pipelines in our model. And then we have something where we can manage it, like with compute and data stores and data labeling. So let's zoom into a few of those things. So data sets. Here we store our registered known data sets. So we can point here to from data sets, you point to data stores, and those data stores can be SQL servers, blob storage, and we can version our data here. Experiments. These ones keep track of our training runs. So we saw that we already submitted a run for our Azure ML of automated machine learning job. All the logging can be found back under an experiment. Then there are pipelines. We're not going to dive into pipelines today, but they are training workflows. So you can create a bigger workflow of all kind of different steps that are needed to train your model. Then there are models. This is the model management where you can register and version your model and everyone can pick them out. Then there are endpoints. The real-time endpoints, here you can find your deployed models. And there are pipeline endpoints. So if you have created a pipeline, you can publish a pipeline and you can kick it off with an easy API call. Then there is compute. Here we can manage our compute. And then there are data stores. And under data stores, you only manage the connections to your different, to the locations where your data is stored. So the first thing, or the second thing we need is compute. So the next thing we need to do is to create and provision our compute cluster. And here I say, Azure Machine Learning Compute, provision this cluster, use standard NC6 machines, spin up, no nodes yet, and you can spin up maximum of 6 nodes. Meaning with the minimum nodes is that if I put there 0, if our jobs are done, all the machines will shut down automatically. If I put 0, or if I put 1, then there will always be 1 node up and running. I say compute target create, and then my cluster is created within the next 10 minutes. And then we need somewhere where our data is. So there is always a default data store. That's the blob storage device that is created when you created your workspace. But you can connect to any Azure blob container within Azure, of course, by providing it the account name and the account key. And later on, you can just connect to those data stores by name. So let's have a look and start coding our own NLP model using Azure Machine Learning. So I always start with importing a lot of dependencies. I always do that in the top cell, but of course, if it is your preference to do that in every cell, that's up to you. I start with my cluster name, with some variables, my experiment name, with my model name, and with my with the name where I want to have my model deployed in which Azure container instance. So we start with setting up our environment. So I've already created the environment, we've seen that. So I'll just say workspace from config and try to connect to it. And here we see I'm now using this my workspace Cybertron in region Western Europe. The second thing is to attach some compute. So here I say compute target, workspace, and my cluster name. If I cannot connect to my compute target, it will actually create one for me. And you see here I've chosen for standard D3 V2 machines. I have low priority virtual machines with a minimum node of 0 and maximum nodes of 4. Because when I'm going to do later on hyperparameter tuning, or when I did automated machine learning, it's going to spin up a lot of runs to compare the different results. So here I have maximum nodes of 4, meaning that there can be 4 concurrent jobs. I create a compute target and wait for it. But I've already created my compute. And this one is called a bumblebee. And then I'm connected to my data store. You can have a look here. You can see that on the data store, here is my default data store. It is just pointing to a blob storage device. In here, I can update my credentials here if I would roll keys, for instance. And under compute, we can find a bumblebee, my compute cluster, and we see that there is actually 1 node running at the moment, and I can have a maximum of 8 nodes here. There are standard D3 machines, 4 cores, 14 gigabytes of RAM. We can adjust. We can here see which nodes are actually running and connect to them. And here we see what is actually going on at the moment. As you see, it is still preparing our automated machine learning run. And under edit, we can specify the minimum and the maximum nodes. So one thing I didn't show you, I am using a notebook here. And of course, you can run these notebooks on your local machine, but you can also use the notebook service within Azure Machine Learning. So what I did for that is under notebooks, I just created a new folder and created a new notebook. Here you can say notebook or text. But to run these notebooks, you need to have compute. And this compute you can create under compute instances. So here I have my compute, it's called Cliffjumper. And basically what this does is run my notebooks for me in Azure. It's a standard D2 V2 machine. They're not expensive. But one thing you should remember is to shut them down when you are done with your notebooking, or however it is called, because they will not automatically shut down for you. You need to do that manual, and you need to start them manual at the moment. So, but the good thing now is that my notebooks are here, and I can just log into ml.azure.com from any machine and access my notebooks running in the same environment. I have not to be bothered with installing any additional packages and updating that machine. So you can do it with the inbuilt experience. This is actually the same, but I still prefer to look at the Jupyter interface. So let's continue with preparing with building actually our model. So now we have a workspace, compute, and storage. We can actually start experimenting with our model and with our data, which I think is personally one of the most fun things about the machine learning journey. So for that, we need an experiment. And the experiment is the glue that holds everything together. So I create an experiment, my new Tailwind Traders model, and then I start experimenting with it. And for every time I experiment it, it will create a new run. And under that run, it will version all the logging, all the models, all the scripts. So I can really go back in time and see how my model is improved or where I made a mistake. We need a training file. Here you see a sample file, but we of course get our training script from the NLP Architect repository. Just take that in and run it. And then when we have our training file, we need to wrap that training file in an estimator. And an estimator you can see as the configuration for the Docker container where your training script is going to run in. So I specify where it can find my training scripts. I can parse parameters in it, so this is configurable. I tell it on which compute cluster it has to run and which script it has to execute when the container is spun up. You can use the conduct package manager or the pip package manager to install some extra packages you need for your scripts to run. So in this case, I want to have Keras and OpenCV in it, but for the other case, we need to have spaCy and we need the NLP framework, NLP Architect repository. And then when we have configured that estimator, we have to submit that estimator to our cluster. And then it will start running and training and streaming back the output to the experiment to our Jupyter notebook. So now it is actually time to do that. So first let's start with creating an experiment. We specified the name above. So this one is called APSA. And then I'm creating the estimator. So I start with my script parameters. I tell it where it can actually find my training data. And I tell it which type of data set I have to use. I have a small and I have a large data set. So the small one is really to see if it is technically capable of training, if there are no mistakes in my script. And if I want to train the full model, I'll specify large, and it will take like around an hour for it to train. So here is create plain estimator. There are also TensorFlow estimators and PyTorch estimators, and tell it where it can find my training scripts. Parse the script parameters, tell them which compute cluster. I can also send additional environment variables in it from here, from the estimate, and it will execute train.py. It will install this NLP Architect script, these versions of Spatie and TensorFlow Hub, and I noticed that it's quite handy to really specify the versions of your frameworks here. We can have a quick look at train.py. File open. Scripts, train.py, and I will point you to a few things. So the first thing you need to do is add a reference to Azure ML Core. But basically you can take any training script and that runs on Python and add this reference. This package is already installed in your estimator. Then you can use this to parse some your input, and then use that input in your script. And finally, you can grab the context and start logging things to your run within your experiment. And here we just log 3 separate things, but most of the time you're doing multiple iterations over your model, multiple training rounds, and then you want to be able to log your accuracy. So if you log a float or an integer under the same name, so this is the name here, and it sees multiple values coming in, it will automatically start creating graphs from that data for you. So that is pretty handy. But let's go back to this estimator. So here we create our estimator, and then we can submit it, and we can ask for some details. And because this trade takes long, I will connect to a previous run. So here in this widget, we can actually see how long all the details. So it will stream real times our logging log files here. Here it's just showing. It will stream everything. If you have like print or anything in your Python script, you will see it back here. And here we see the values it actually logged at the end of the script. So this is also available in Azure Machine Learning. So if we go to experiments, we go to APSA, and we go to run 4. Here we see exactly the same thing. So under metrics, we see those 3 things that are logged. Under output and logs, we find all the log files back. Exactly the same as what we saw in the widget. Under snapshot, we find back the training script. This is the script which was just submitted to our estimator. And we here have some new features. We have explanation and fairness. So pretty cool. We can see on which compute target, the duration, when it was done, which run, and which actually models were all derived from this one. So then, the last thing we will need to do now, before anyone else can start using this model, is actually register this model. So here we say run, register our model. We give it a name. We tell it where it can find our model. Tell it which framework it was, which version, can have a description. We can add some additional text so we can find it back later, and we can specify the resource configuration. So later on, when you deploy this model, you can actually use this recommended resource configuration. You don't need to use it, but it is kind of the recommendation the creator of the model put in there, so you should pay some attention to that. So let's run it. And now we have registered number 12. So we can go to model management. Here we see the model from the run. You can click on that. And here we see our tags. We see the description, the framework, and we see here, this is the very important thing, which run has generated this model. So we can go back to this run, read the log files, and from there we can go back and find out where it got the data from and which training script was used. So it is already traceable from the model perspective. So let's dive in a little bit about what happened when we submitted our job to our cluster. We say submit, and then it snapshotted our folder with our scripts and uploaded it to the experiment. Started creating a Docker image according to our estimator specification, and then it deployed that Docker container to our compute target, in this case our Bumblebee cluster. It mounted our data stores. So in our training script, the data is available in a virtual directory in that container. Now for our script, it's just looking in the directory. We don't have to be hassled with mounting file shares and so on. It is all done for us. And then it launched the training script. Just launched the Python script we wanted to do, and it started training the model. So one thing that is important to know, I forgot to mention, is that these training scripts deliver output. They deliver the model. So you have to save the things you want to store or want to keep in the outputs folder. Because, of course, the Docker container will shut down and detach and so on, and otherwise all your data is gone. So if you save something in the outputs folder, then it will automatically be copied over back to the experiment. But while your script is running, it streams all the output directly to the experiment, and you can connect with your Azure Machine Learning widget to your experiment to follow it real time. And when it is done, it copies over the outputs to your experiment. Registering the model, when you're happy, you can first, of course, download the model, test it, do some tests before you register it. But then you say, run, register my model, you can find my model in outputs. So let's have a final look here. Oh yeah, that I can show you that is that the model is found back under experiments. Here, run 4, under outputs, and here is the generated model by the NLP Architect framework, and basically a big CSV file what is generated. So we have registered our model. So now we can download this model, these two files to our temp directory, and actually load in the model, trying to analyze these sentences and see what and visualize them. So here we had the 3 input sentences, it processed it, and now it is visualizing it here with this statement. So now we see that we can say love the sweater, it's positive, but hated the pants, it's negative. Really great outfit, positive, and I really like the shirt. The shoes, negative, are bad, and a perfect blouse, it's positive. So that's pretty cool. So our model works for this case. So now the thing we want is to actually deploy our model somewhere so that everyone else can also use it. So let's start deploying our model. And to do that, we need a minimum of 3 things. We need, of course, the model. We need a scoring file. The scoring file will load in the model and will be able to do predictions and use the function we have created in the model. and we need to specify our environment. So how and where can our model run in? We wrap those two together. Azure Machine Learning Service will build a Docker image for it, and we can deploy those Docker images. So how does a scoring file look like? You, of course, need to start with importing your model, but then basically there are two methods you need to fill. So first there is the init method. This one is called once and will load in your model. As loading in models takes time. And then there is the run method, and this method is called every time a request comes in, because we're basically building an API. Then there is an environment file. This is a conda environment file, and we just specify which packages need to be installed in this Docker container. We wrap those things together. We specify the runtime is Python. This is the scoring script. This is the environment file. And then we can use Azure Machine Learning to deploy this configuration to an Azure Container instance or to an Azure Kubernetes service, which needs to be connected to our Azure Machine Learning Service. Deploying to ACI can be done from code, but you can also use Azure DevOps to do this. But to do it from code, we say Azure Machine Learning website, this is our deployment configuration. Here I specify CPU cores and the memory very specifically, but you can also get this configuration from your model. Because when we register the model, we specify this configuration. And then we say model, deploy it to this Azure Container instance, use this model, use this deployment configuration and this InferenceConfig. So let's do that and see this model actually running. So here I can load, with this command, I can load my model, because maybe you want to do this in two different notebooks and not exactly in the same notebook, or want to do this in a Python script or somewhere else. So here we can load the model. It's a model, the name and the version. So our model was version 12. So now we can load our model and we have more model version 12 loaded. Create our environment file. I'm using the pip package installed pip packages here as Azure defaults. I want to have some monitoring. I of course need the NLP Architect framework installed, and I need spacing. I say, okay, conda create an environment from these pip packages. I'll write it, and then later on I create an environment from this, an APSA environment from this environment file, and specify some environment variables. Create this InferenceConfig, my deployment environment, and my entry script, so my inference script. And then I start specifying my deployment configuration. So I say how many CPU cores and memory. And here you see I load this information from my model. So this is already done here. This configuration. So if my data scientists think, okay, this model is way more heavy, probably use 2 and 4 gigabytes, I don't have to adjust it later on here anymore. And then when I have my deployment configuration, I will actually deploy my model, specifying the name, the model, InferenceConfig, deployment config, and that it has to override this Azure Container instance. So what happens now is that it will just it creates a new Docker container and it will deploy it to exactly the same Azure Container instance, meaning that this container instance will be down for a little bit while redeploying it. If I put this to false, it will give an error if the Azure Container instance already exists, or it will create a new one. So you have to look in how you want to deploy this. But for dev and test, it is perfectly fine to just override the same instance. For an Azure Container instance, you only have to do one thing more, and that is connect to your AKS compute instance. And then it is basically the same, only your deployment target is a little bit different. And this goes way faster. So if you go to compute and go to inference clusters, this is the place where you create your AKS. So you can use an existing AKS service, or you can create a new one here. We just say NDC, probably it already exists, but let's guess our luck. We say where we want to have it, choose a virtual machine size, wait a little bit, and it will create this AKS cluster for us, and it will also deploy lots of other containers to actually help you manage your deployments. So this, if you use this, your deployments go extremely fast, and they're nicely load balanced and so on. So this is pretty cool to dive in if you want to use that. So now this thing is deployed. I've already deployed it. So we can connect to our ACI service. Deploying takes around 5 to 10 minutes. So I can connect to my latest ACI web service by just giving the name and the workspace. And then from that ACI service, I can ask, give me the scoring URI. I can click on it, and here it says, oh, I need text as input. So what I've done, I've written a small web app that actually uses, good, it is working, that takes a URL as input, and you can send some text to that URL for you. And then it will prettify the result. So we have the same sentence here again, love the sweater, but hate the pants. So let's analyze that. Just now send that to our endpoint. And here we see that even a little bit more with more detail, that loved is an opinion, and sweater is the expect. Hated is the opinion, and pants is the expect, and the colors actually show us how they are related to each other. So that is how it works. So in the meantime, if you have any questions about it, feel free to put them in the chat in Slack or in the chat from here. So, small resume, what have we seen? We have seen Azure Machine Learning Service that can actually help us from managing our data, to training, to deploying our service, and then we consumed this service. And everything is always available on the short link you see in the bottom, so you can redo this demo yourself and look at how we did this. So the last 12 minutes, I want to talk to you about distributed hyperparameter tuning, because we've now trained our model, but we probably need to optimize it a little bit anymore. So what is distributed hyperparameter tuning anyway? So what are hyperparameters typically? When you see a new state-of-the-art model that has been open sourced, whether it is like BERT or in this case our aspect-based sentiment analysis model, typically you see those models trained on certain data. The performance of the model is dependent on the distribution of the data that is being trained on. And there are a set of parameters that are configured as part of the model that are optimized for that given data set, so that the researcher who is publishing the model can get the best possible performance. Now, when you take these models and you run them on your own data or train them on your own scenarios, you're going to have a different distribution of data. Your data is just different. So these hyperparameters might need to be adjusted. Otherwise, you see a big gap in performance of your model when you apply it to Tailwind Traders company data, comparing to what's written in the leaderboard or in the papers. So this can be a real challenge going through this manual hyperparameter tuning. Typically what we do is we take a data set and we come up with an algorithm, then we configure these parameters to build our first model, and then we start changing those parameters. Again, we build a second model and we try to And we do this a couple of times until we max out our potential of this algorithm. And then we might change our model, and then we have to do this all over and over and over again. And that is a really tedious, repetitive, and really expensive process. And of course, we can automate this. So, well, the Azure Machine Learning Service helps you manage this by running distributed versions of your model and allowing you to choose which are the primary metrics. You want to optimize based on the hyperparameters that you provide. And it provides a bunch of different policies, such as banded policy, medium stopping policy, and truncation policies that enables early termination. So if you see that a certain set of hyperparameters just isn't providing the best possible result, it will terminate those run jobs and release and run and prioritize the other ones for the models that are much more promises until you find the most optimal set of hyperparameters. So let's see how this actually works. So I have a new notebook. Go on. Yeah. So here is a new notebook. This is, here is the HyperDrive notebook. So I start with importing those dependencies again, connect to my workspace, to the compute cluster, to the default data store, and to our experiment. So this experiment is now called APSA HyperDrive. So the only thing I now have to do is specify the parameters I want to have sampled. So what it is doing a random number between 2 and 5 for these 3 parameters. And in our training script, we have those 3 parameters already here. But what did it before, it defaulted it to these default settings. But now we're going to use this random parameter sampling to push in random parameters. I'll define a termination policy. And here you see that it is exactly the same estimator as we used previously. But the only difference we do now is to wrap that estimator into a HyperDrive config. We specify the estimator, we specify the parameters that need to be sampled, and we specify which a metric it has to monitor. And that is actually one of those metrics that we specified here when we were logging. So it is monitoring that output. And then we specify a goal. So we have to maximize this value. Total runs is 16 and maximum is 8 concurrent. And then we submit, instead of the estimator, we submit the HyperDrive config. And then we can use the details to show. So the only difference now what we see is a summary of all the different runs. So here we see that it is generated like 16 or 18 random runs. And if we click on one, we see the exact same result as what we would see when we would run one estimator manually. It's creating this nice graph for us. So we can follow this line and see that run 9 delivered us the best model. Some other cool graphs here. We can also have it in 3D. We'll have a look at it. And we can also use a small line of parameters to say, shift run, get us the best model. The best run is 9, and the F1 score is this. So we can go also here to experiment. We see APSA HyperDrive. So here we see that run 1 succeeded. We can click on that. And the thing that came in now is that we have a lot of child runs. So here we see all the individual runs with all the different parameters used and the duration of the runs. We can click on that run and see here the parameters. Of course, we can find the logging, we find the output. So everything is nicely grouped here and grouped under one HyperDrive run. So this was very quickly, I realized that. So there is more available on our docs website, more tutorials on how to do that. So let's wrap it up. We've seen a very easy scenario to do text analytics with cognitive services. We have built a small model, a baseline model with automated machine learning. We have built a more advanced model using the NLP Architect framework from Intel with Azure Machine Learning. And then we optimized our model with HyperDrive and with hyperparameter tuning. If you want to get started, I would recommend this tutorial on our docs website, how you can start training and deploying your model with a very, I wouldn't say easy because that is dependent on which journey you are in, but with a compact and small training script. More docs. Of course, we have Microsoft Learn. You can get your certificates. And these are the resources I want to close off with. So if you want to get started at Azure ML and the Python SDK, go to this link, and there are a lot of tutorials on Medium on how to do this. So I want to thank you all for listening to me and enjoy the rest of your conference. And if you have any questions, I am available in Slack. So thank you all, and I wish you a good evening.